Dividing by zero. Can you divide by zero? When confronted with the question, can you divide by zero, students will give one of two answers, yes or no. As a mathematics teacher, it is your job to make sure that they understand the answer to this question. If this question is followed with the question, why can or can't you divide by zero, you will get an even larger variety of answers. Can you divide by zero? When I asked a variety of students this question, the primary answers that I got were yes. It requires imaginary numbers and is trivial, or yes, and it requires the use of limits. Or I got no, and it is undefined, or no, and you can't separate anything into zero pieces. Now, let's examine these questions. It requires the use of imaginary numbers and is trivial. Well, since 0 equals 0 plus 0i, and we can look at it as a divided by 0 plus 0i equals b, this gives us a equals b times 0 plus 0i, which gives us a equals 0 plus 0i, which on the surface seems valid. But all that it is telling us is that 0 divided by 0 equals 0. Since 0 divided by anything equals 0, this is completely ignoring the entire denominator. Now, it requires the use of limits. While the use of limits can be used to divide by 0, what you are really doing is dividing by a number that is approaching 0. This means that the number never actually reaches 0, and therefore you are not actually dividing by 0. Now, what about the no's? It is undefined. Well, this is a true statement. Anything divided by 0 is undefined. Why, however, is it undefined? A common answer that you will receive is that anything divided by 0 is undefined by definition. However, this is not definition. We will come back to this in a little bit. You can't separate anything into 0 groups. When I asked the student to explain what he meant by this, he said, if you take 3 beans and divide them into 3 piles, you get 3 piles of 1 bean each. However, if you try to take those same 3 beans and divide them into 0 piles, you will never run out of beans. While this is accurate, if you follow this logic further, you run into a different problem. This means there are other numbers that you can't divide by. This is intriguing enough to deserve more investigation. If we try to separate a group of objects into 0 piles, we will never run out of objects. Therefore, this is impossible. Well, what if we try to divide a group of objects into a negative quantity of piles? If we take 6 objects and separate them into negative 2 piles, we will get piles of negative 3 beans each. But how can we represent a negative object? Do we represent it by gaining an object? Then, if we have a negative object, doesn't that mean that we still will never run out of objects because we just keep gaining more? Since we know that 6 divided by negative 2 equals negative 3, we know that division by negative numbers is acceptable. But what makes division by negative numbers acceptable when division by 0 is not? The answer to this question is based off of another question. What is division? Division is really multiplying by the multiplicative inverse of a number. But what is a multiplicative inverse? Multiplicative inverse is the number that you multiply another number by to get 1. For example, a times b equals 1 means that a and b are multiplicative inverses of each other. Well, in that case, what is the multiplicative inverse of negative 2? Well, since a times negative 2 equals 1, then a equals negative 1/2. Therefore, negative 2 has a multiplicative inverse. But what about 0? In order for 0 to have a multiplicative inverse, x times 0 equals 1. But by definition, anything times 0 equals 0. Therefore, 0 equals 1. But 0 does not equal 1. Therefore, 0 does not have a multiplicative inverse. Thank you for watching this presentation on why division by 0 does not work.